Continue mechanics. Introduction to fluid mechanics. The end of a tank containing water is vertical and is in the shape of a semicircle as indicated in the sketch given below. To determine the hydrostatic force acting on the end of the tank, divide the end of the tank into n horizontal strips. Such that the area of each strip is equal to its length multiplied by its width. If the horizontal strip is x1 meters below the top of the tank and the surface of the water is 1.5 meters below the top of the tank, then the force acting on this strip is equal to the pressure multiplied by the area. Given that the end of the tank is in the shape of a semicircle, we have that x1 squared plus x2 squared is equal to the radius of the circle squared, where the radius of the circle is equal to 3 meters. Given furthermore the acceleration due to gravity and the density of the water, we have that the force acting on the horizontal strip can be expressed in terms of x1 only. The resultant hydrostatic force on the end of the tank is obtained by adding the forces on all the strips and taking the limit as the number of strips increases to infinity. Therefore, the resultant hydrostatic force on the end of the tank is obtained by integrating with respect to x1 from 1.5 to 3. The moment of the hydrostatic force acting on the horizontal strip is equal to the distance of the horizontal strip below the top of the tank multiplied by the force acting on the horizontal strip. The moment of the resultant hydrostatic force is obtained by adding the moments for all the strips and taking the limit as the number of strips increases to infinity. Therefore, the moment of the resultant hydrostatic force is obtained by integrating with respect to x1 from 1.5 to 3. Dividing the moment of the resultant hydrostatic force by the resultant hydrostatic force, we have that the center of pressure is approximately 2.37 meters below the top of the tank.